This video today is all about magnetic fields. To fully understand how a magnet works, we must have a firm grasp on the behaviour of magnetic fields. The magnetic field is the area surrounding a magnet in which it can exert a force onto a magnetic object. The magnetic field weakens over distance, so the further away the object is, the less likely it is to be attracted by the magnet. Let's have a look at the magnetic field around a bar magnet. These lines represent the area of force, or the magnetic field. As you can see here, the magnetic field is strongest at the poles of the magnet. And these lines of force represent the way magnetic field stretches out from north to south. See here, the North Pole is exerting a strong force looking to attract a magnetic material, or the South Pole of another magnet. The magnetic field lines always behave in this predictable manner, north to south, because unlike poles attract or opposites attract. So remember the bar magnet that we hung from the roof, and compasses, which are really just small bar magnets on a pivotal point? Well, why is it that they will always orientate themselves to point to our geographical North Pole? Let's have a look at the magnetic field of our Earth. Does this look familiar? If you think that it looks like the magnetic field around our bar magnets, well, you would be right. The Earth does act like a giant magnet, although it doesn't really have one inside. But if we imagine the Earth is a magnet, we can see why compasses point to north. If we look at these side by side, we can see that up here, at the top of the geographical North Pole, is really the South Pole of our imaginary magnet. And what do we know about magnetic poles? That's right, unlike poles attract. That is why the North Pole of our hanging magnet and our compasses will always point to north, because they are attracted to the South Pole of the imaginary Earth magnet, or the Earth's magnetic field. Okay, now we can look at repulsion and attraction. Okay, so this is the representation of magnetic fields during attraction, this one here. North and south are facing each other, and therefore they are pulling towards each other. North and south, the magnetic force is strongest at the poles, and the field lines go from north to south. Okay, they also go from north to south here, and north to south here. This north here is stretching out looking for another south. Okay, in the second diagram we have like poles together, north and north, and they repel. We can see the behaviour of the magnetic field here and here and here and here. Okay, north and north are repelling and pushing away each other. Now let's have a look at this phenomenon with some photos of iron filings showing the magnetic field lines of the magnets that are underneath the paper. In this photo, the magnetic fields are pulling towards each other. You can see that they are stretching out between them. These are unlike poles, and in this photo you can see that the magnetic fields are repelling. Okay, they are not connected, they are pushing against each other. Okay, so these are like poles. Let's have a look at another picture. Now this picture is of some magnets that do not have their poles marked. Do you think they are repelling or attracting? Look at the magnetic field lines. What do you notice? Okay, so we can see that they're stretching out towards each other here and here, here and here. Okay, there's field lines that are stretching out from both ends, but in between here there's nothing. Okay, those field lines are pushing against each other. So they are repelling, yes? Okay, you can see the magnetic field lines connecting to north and south, but there's nothing in between these poles. Okay, now the last picture. Here we are. Look at these magnets. Okay, what you can see by the way they are arranged that the unlike poles are next to each other. So we have the north and south and the north and south. Okay, the way that we arrange them in our box at school. So they all have their unlike poles next to each other. They're attracted. Look at the way the magnetic fields are behaving. We have north and south, north and south. We have north and south, north and south, north and south, north and south. And did I do north and south here? I did, didn't I? That's right. All right, and here in the middle, this section here is where maybe this north bit is pushing here, and they're just that little spot of repulsion in the middle where they're sort of not quite joining up. Okay? So that was a lot to take in, right? The magnetic earth is a pretty tricky concept. So I really do think that you should pause, rewind, replay this video as often as you need to. Okay? Remember that you need to summarize this video, find out what the main points were, put them in the Google form that is the link underneath the video on the website, and you can always ask me a question in that form if there's something that you still need to have clarified, and we'll go over them at the start of the next lesson. Okay, so thank you, and I will see you in class.